Welcome back to Monroe Live, everybody. This is our second episode with our Giga Texas Model Y. And for this episode, we're going to spend some time under the hood. So we have a Model Y with Giga castings. Everybody's known that. When we first picked the vehicle up, I pulled off the trim panel and lo and behold, we saw them. It's one of the main indicators to know that it's using their new technology. And now we're getting into some of the finer points. So at Monroe & Associates, our job is oftentimes to advise clients on how to improve and get better. We offer lean design training. Sandy Monroe is currently in Italy doing some training for a client over there. And the first thing I noticed when looking at the heat pump hanging off of this crosscar beam was the routing of the high voltage wiring for the heat pump had changed. And I remember the elegance with which this was designed. This is from our 2020 Model Y. They didn't even use a fastener up here. This little portion right here hooked over a small little ear. That ear is still there. I don't know if you can see that, Zach. Even though that ear is still there, they've chosen to route the high voltage wiring down, and they carefully secure it here on this plastic piece. Now, Elon Musk was interviewed by Tim Dodd down at SpaceX probably last year, and he said that many engineers will spend time designing and refining a part that shouldn't even exist. This is a perfect example of this. And we have Carl here to shed some light on some of the other pieces and parts that we found that have changed, some for the better, and some things we found that kind of make us question a little bit. So the first thing we found was essentially the elimination of this part. Now we're going to talk about this little bracket here. On the Model Y that we received in 2020, it had a very similar bracket. Now Carl's going to run through the differences that we found. So go ahead, Carl.
So all right, the previous bracket was a steel bracket, as you can see, connects with a magnet. The formation is very similar. However, they have used an aluminum bracket to connect to the Giga casting and then also to the front fender. So the question becomes, all right, what was their benefit in doing that, and what was the process in doing that? So some people might think, well, they had to modify their tools. They may have. Whenever you have something like this that you're trying to stamp, think of it as a C-section. And if you are stamping up and down, sure, the aluminum is thicker. I have to account for that thickness. So if I spaced out my cavity this way, the problem I have is on my side. My side is in shear, and shimming the part does not help that. So if they actually wanted to change their tools, they'd have to actually go into their tool, machine and mill out that edge. But you have a problem with that. You have to be able to put your tool back into a mill. You have to be able to perfectly align it so that you can mill that out. But those tools are still in use. So if they were carrying over those tools for current production, or carrying over the part for a current production while they're designing the new aluminum, they would have to do a bank build, meaning they would have to run a bunch of extra parts to set on the shelf to use in the time frame while they're modifying the tool. The more practical thing was this most likely was a brand new tool making a very similar part but designed to the new material.
Yeah, and the Giga casting stops right here, and they still have the sacrificial crush can. This piece would also be sacrificial in a moderate impact. I don't know, maybe 15, 20 miles an hour, this would be damaged. You're going to have a really, really hard hit to get into the casting right here. The Giga castings in the rear go much further back. And now we want to talk about core structural monuments. So you have these two crosscar beams, one right here in steel, which holds up the thermal system, the heat pump system, octo valve, and the battery. Then you have this smaller aluminum extrusion. Now, at first blush, it looks exactly common to the one we pulled out of the Model Y. And if you're wondering why there's some dots there, this one was 3D scanned. But we noticed that the part number is completely different, and it says revision 1.4. So naturally, we're kind of curious. We grab the part. We wonder if the distance changed across car. It may look shorter at first, but this is actually a trapezoidal shape, so if you flip it over, the width is exactly common. The thickness of the extrusion is common. the shape of the extrusion is common. So what changed? And we quickly noticed that they used 2 riv nuts. So you have a threaded feature, and they're put in essentially like a rivet. And these are the 2 interfaces for, I believe, the bottom of the frunk. And this is what a riv nut looks like. There's many shapes, sizes, configurations to use. They're using some that are similar to this riv nut right there. These 2 are eliminated, but it'll be interesting to see when we get this part out if they've also eliminated 1, 2, 3, 4. So 6 riv nuts may seem inconsequential. These would cost, what, about 1/4 cent, maybe 1/2 cent, with the actual processing, maybe 3 cents to 5 cents for all of them. What do you say, Carl?
I don't know. I've used mostly plastic fasteners for my interior components, and my plastic fasteners range from 3 cents to 15 cents depending on the fastener. The metal riv nut, I don't know where that would be in that price.
Well, anyways, it's in the cent range. Yeah. But 6 of them eliminated from every vehicle is something that anybody buying a Tesla, or actually any vehicle, would never notice. So this thirst for improvement is what we see, because when we received that first Model 3 in late 2017, early 2018, we opened the hood, we took the front trim out, and we saw components that look nothing like this. Even though the Model 3 and the Model Y are on the same architecture, they had weldment shock towers, they had the super bottle, not the octo valve. So they've since eliminated that all with the heat pump system, and they've even eliminated the lead acid battery and replaced it with this lithium ion one. Now Carl and I are going to talk about the other cross-car member. We're going to, and the stamp. This is a steel tube. I don't know. The steel weldment that goes between the 2 shock towers. The dimensions remain common. So once again, to get maximum value out of this gigacasting, they grew it to mate with the exact mounting location of the existing part. Having to create a brand new crosscar beam is added cost and added weight that doesn't bring value. And even if you notice some of these bosses on the gigacasting, they have grown all the way up to interface with the fender foot, this little fender bracket. This is the identical geometry of a Model Y without the gigacasting. Now, Carl, you were talking about the revision right here on the numbers. So we see 1075043E. Yep. This one is
an F. So when we were trying to look at the differences, it all seems very similar to me at first glance until I noticed the landing pads for these bolts. There are some differences in their overall size and in their weld pattern compared to what we see in this crosscar beam.
Yeah, and then the biggest change that we see hanging off of this is this large aluminum bracket. So back when we covered the thermal system for the Model S Plaid, I remember comparing this aluminum aluminum casting to the Model S Plaid, which was plastic. And I said, I bet dollars to donuts that when we get our new Model Y, it's going to have a lithium-ion battery. They're going to eliminate the aluminum one, and there will be a plastic one. Lo and behold, what do we have? We have a plastic structure holding up the lithium-ion battery. This battery is not cantilevered off the beam, which on the Model S Plaid it was cantilevered off the beam. But the structure that's holding up this large AC compressor, you know, even though there are a bunch of isolators right there, it is a plastic piece. There you go. One thing that has remained very similar throughout all of the heat pumps we've seen for Tesla is the routing and configuration of the pressure and suction line for the heat pump. So this was from the original Model Y that we received, the R1234YF. And if you notice, they're slightly different. They've increased the size of the, I believe this is the suction line, not the pressure line. But yeah, it's bigger. And at first it's like, okay, so when did this change come into play? is it common between all other Teslas? This came straight from the Model S Plaid. Now, the part number is, I believe, near identical. It is, yep, you have 00C and 00C. So the Model S Plaid that we received, built in Fremont, and there's a Giga Texas Model Y, are now using the revised and maybe improved lines for the R1234YF. So these are the small improvements that we see happening over time, and it can even be from little bends in the line to the thickness of the hose. For whatever reason, they've decided to move on and improve. The next thing we're going to cover is the washer bottle. So we're trying to identify pieces and parts that are common and that have changed. Essentially, Monroe & Associates, we've already done a full report on the entire Model Y, so we don't want to waste any time reanalyzing parts that are common. This washer bottle is a two-piece design. The one from the Model Y that we got in 2020 was very difficult to remove. I can barely do it, but I can. And we noticed that this upper piece, although it looks similar, you look at it, it looks like the mounting provision is similar, but it's not. The attachment feature for this hose right here that goes up to the sprayers, it only routes through 2 of these little ears, and the older version they had 3, so they eliminate 1 ear. The shape and the flow of it is similar, but slightly different. The part number is also completely different. So this is not a revision change. They have, let's actually compare them. The geometry is also different, not common. But what's interesting, this is not part of the tank. So you would have thought they were using a common tank on the Model Ys and the Model 3s and then just changing this part, but that's actually not the case. The mounting foot right here mounts to this small boss on the Giga casting. Can barely see it, probably not even, yeah, right under my finger there, actually right there. And this mounting provision moved to the opposite side. Now, you may be thinking, like, come on, Monroe Live, come on, Corey and Carl, why are you pointing out these tiny, minute differences? Because these matter. Carl, you want to talk about the tooling complexity and the line complexity when you have multiple different parts?
It winds up mostly being in the handling. If I have multiple different parts that I have to produce at the same time, I have to have floor space, I have to have package space, I have to manage the injection mold, blow mold tools, you have to have shelf space for all of that. It gets to be a huge problem. Now, when I was dealing with mostly low volume, that was a huge issue. When we had low volume, we had just a few number of cars going out, but if we had high complexity and lots of different types of components, the amount of storage and inventory that we had to maintain in the plant, just that cost wiped out any cost in trying to build a new tool to kit a common tool.
I have a question for you.
Your part here, your elimination of that ear. All right, one thing you could say, oh, well, they eliminated a little bit of material. I bet you the material elimination was nothing. It's the operator who has to feed that wire through 3 different tabs to where this one, you just hook it. The assembly line efficiencies make up your savings more than just the material saving.
Yeah, and then I have a question. So most likely this version of the vehicle will only be built in Texas right now and eventually in Giga Berlin. So you will have a dedicated, set of parts for Texas and Berlin. And if they are still building Model Ys in Fremont, they'll most likely have the other design. So they have the luxury of building the same vehicle in 3 or 4 plants, so you could get some efficiencies there.
Yes, depending on the supplier base. If this is low molded by Tesla or if this is made by a supplier that has to be shipped in. But you would most likely try and keep components as local to your plant as possible because you never want to ship air. And this is really a lightweight, hollow thing, but you put a bunch of these in a box and they take up a lot of room that you have to ship across the world if they're going all the way to Berlin.
All right, so moving on to the the next thing that we found, which is pretty wild, is this bracket right here. So we found this aluminum bracket, which is the under support for this crosscar beam. And we can see a little bit of purple structural adhesive between the Giga casting and this aluminum stamping. But there's also spot welds. I can feel 1, 2, 3, 4. Get a light on there, Zach. See if you can show those spot welds. Yeah, get it. Yeah, there you go. And I'm no metallurgist, and we do have some welding experts in the building. Carl and I just found this, and we're going to bring over our experts and get a second and third and fourth opinion on this. But when you weld, when you spot weld to a casting, you're going to be modifying the properties. Correct me if I'm wrong, Carl. What do you think is going on there?
Normally, that additional heat that you put into a casting creates a brittle spot. The temperature that you would normally weld, if it was metal or whatever type of metal, a stamping to a casting, you would have to normally have a higher temperature on the stamped part than you would need to weld into the casting without trying to burn through the casting. So the problem that you end up having is, am I actually getting a clean weld going between these two, even though they're both aluminum, dissimilar materials?
Yeah. What I find odd is they're using threaded fasteners all throughout. So you have a threaded fastener right here for your upper connection of a control arm. You have threaded fasteners going through holes. You have tapped and threaded fasteners here. I know that the clearance is very close here, but this is physically mounted. This does not vibrate.
So the question that comes up though is, if they are welding, you put all of that effort in making this casting, why isn't that just an ear off the casting? There's probably something in it that prevented it, but it seems weird to have to weld a fixed component to a casting.
Yeah. So I wish that was integrated. I'm guessing it's a packaging constraint. It's a trade-off they most likely made to be able to maintain this beam. Because if they changed this beam and got rid of this, they could have had a nice big ear sticking out similar to this or that. Or this actually is in die draw, so maybe they couldn't, yeah, you can't put a slide in the middle of the tool.
Okay.
That's why. Yeah. So the casting, the tooling's going to open like this, so you're going to be in die draw there. So having an internal slide isn't going to fly. Okay. So I'm guessing that's it. So
for plastics, I can do that, but yes, for this, it's another matter.
We answered our own question. All right, so we've kind of exhausted the small, minute changes and details that we've seen. We're going to find a lot more. We have our whole team pouring over this vehicle. This is the second video of roughly 6 or 8. Carl already did a fit and finish video, which you'll see after this, and we did notice one small fit and finish snafu. There is a fender locator, and Carl, you want to talk about this fork?
So in the other video, we were talking about the outsides of the fenders and how we were seeing inconsistencies. Our hope was, because of the casting, you can integrate a bunch of different parts, a bunch of different attachment features. You should have a better build quality, in theory. However, things do happen. This fender is brought on, bolted in place. Somehow they completely missed this locator. So the question becomes, is that a primary locator? Is the aluminum bracket overpowering it, sucking it in so that it cannot attach? So there's something in this system that is out of place, out of position.
Yeah. And overall, the FEM, the front end module right here, could be mounted too far over to the right of vehicle, or the fender could be mounted too far to the left. And you can see the fender is actually pulled very far in that direction because I can see the hole exposed there. Yep. So the fender does have some play moving this way, but they were probably trying to get good fit and finish in the plant. And this is not supposed to be bent up. This should be down flush like this, but this is a part that you would never really see once you put in all your trim components. And I think that's about it. And now to wrap up, just a reminder, we are selling the 4680 cells from the pack. We will be doing the cover off video either very soon or might actually be before this. Carl, thanks for coming on. I didn't really introduce you at the beginning of the video because you're like our second or third pro here. It's probably your 20th video. Sandy is still in Italy. I know we get a lot of comments, where's Sandy? I want to hear what Sandy has to say. Unfortunately, we've been so busy that we've been traveling quite a bit, and I flew back just to be in a lot of these videos. And thank you to all of those who have subscribed. We're approaching 300,000 subscribers. We got about 2,000 since the launch of our first video. By having subscribers, this is what allows us to do this. Without people watching, we cannot justify not only the purchase of the vehicles, Carl's time, my time, and the time of our near 100 employees here. So thank you to everyone who's subscribed. It actually really, really helps. And that's all we have for today. So thank you very much.